The higher you climb into the air, the stronger the wind. So why don't we use huge balloons to lift wind turbines to heights of over 1,000 meters? This is no longer a crazy idea. In fact, one company is already doing just that. It lifts XXL wind turbines 1,500 meters above the ground, which can supply around 2,000 households with 7,000 megawatt hours per year. Today, we will clarify how big the potential of such wind turbines really is, how they work technically, and how they compare to conventional wind turbines. And with that, welcome to BenEI Mind. Whether in Germany or worldwide, the expansion of wind energy still poses a problem of volatility because of the natural fluctuations in the power grid due to weather conditions. Sometimes it is too windy and we have too much electricity, sometimes too little. Storage facilities already help, but it would be even better if wind turbines could simply supply electricity constantly and predictably. And this is exactly where these floating wind turbines from a Chinese company come into play. But also companies from Germany and other countries are working on similar concepts. They use high-altitude winds and could simply eliminate the problem of volatility by that, and the technology is actually quite promising. Above a certain height, wind speed simply increases and above all becomes more constant. One reason for this is that higher up, the wind is not slowed down by buildings, vegetations, or certain types of terrain. In concrete terms, this means that when wind speed doubles, its power increases eightfold, and the higher you go, the more pronounced this effect becomes. A professor from Stanford therefore says that high-altitude winds could supply so much energy that we could power the entire world population 100 times. And that is precisely why researchers have been working for years to harness high-altitude winds for wind turbines. Incidentally, this can be seen around the world. Wind turbines have become larger and larger in recent years. In Brunn, in East Germany, for example, a wind turbine is currently being built that will be 365 meters high. That is almost as high as the Berlin TV tower and almost 3 times as high as normal wind turbines. Incidentally, I have already climbed the wind measurement tower for another video, and that will come here on this channel very soon. So, don't forget to subscribe. And by the way, please keep giving me feedback in the comments. Some people told me last time to speak a bit slower. That's what I tried today. So, give me feedback if this is good for you or not. Okay, back to the technology. So, the startup today has completely different plans. They want to harness the wind at an altitude of 1,500 meters and achieve an energy yield that is 27 times higher than with normal wind turbines. And they want to do this with floating wind turbines. We will take a closer look at exactly what the company Sarvis, how it's called, does in a moment. First, let's take a look at such systems. SARS stands for Stratospheric Airborne Wind Energy System. So, they apparently want to fly really high up into the stratosphere. The wind turbines are built in a way that they don't need, like a normal wind turbine, a strong foundation or tower. The wind turbine belongs to the category of airborne wind energy systems. These always consist of 2 parts, a generator and an aircraft. There are basically 2 different types. Ground gens, where the generator is located on the ground. You can think of these systems as a kind of a yo-yo. So the aircraft pulls out the rope during the flight, which drives the generator on the ground, and then the rope is reeled in again to start a new cycle. And then there are fly gens, where the generator is directly on board and generates electricity constantly. The electricity generated is then transported down to the ground station via cable. From there, the electricity is fed directly into the grid or into a battery storage system. And that brings us back to the system from China, the S1500 system. And it has not just 1 generator, but 12. These micro-generators each have an output of 100 kilowatts, giving the S1500 a total output of 1.2 megawatt, and according to the manufacturer, it is the first model of its kind, with a rated output in the megawatt range. The micro-generators don't just boost the rated power, they are also super light because they are made of carbon fiber. So the whole system of the S1500 weighs less than a ton. Unlike other airborne wind energy systems, which tend to use aircraft, such as classic kites or dragons, drones, parachutes, or even small aircrafts, the S1500 system is more like a zeppelin. The ring-shaped shell is filled with helium. Such air power plants, which float in the air, are called buoyant airborne turbines, or BAT for short. The helium ring gives the model extra static lift, and this is a decisive advantage because it allows the device to remain in the air even in changing wind conditions. Drones and kites can't do this and have to be landed when the wind is too strong or too weak. Before we get to the exciting part of how much electricity a bed could actually produce, let's take a look at the current status of the S1500. The manufacturer says that they want to connect the turbine to the grid as early as next year. However, the model is currently still in the middle of the testing phase, but development is progressing really well. The first model in the Zara series, the S500, was only launched last December. At that time, the model only reached a height of, well, the name says, 500 meters and an output of 50 kilowatts. But in January, the development continued with the S1UOO, and now in September, the S1500 has ventured on its first test flight in the Gobi Desert. Unlike its predecessors, however, it only flew just above the ground. Among other things, the test examined whether the turbine really delivers the expected performance and how it functions under different conditions. For example, during the day and at night or in very strong winds, according to the manufacturer, the S1500 definitely performed well during this test. What should they say otherwise? But the question remains, are floating turbines really an alternative? Two normal wind turbines. As mentioned, the output of 122 megawatt is much higher than that of other BATs. However, the S1500 still has a lower rated power than most modern wind turbines. Depending on the model, they now have an output of up to 6 megawatt. But here's the catch. Onshore turbines average just under 2,000 full load hours per year. That's 2,000 hours, during which the wind turbines runs at full rated power. Nominal output is the maximum output of the wind turbine. And since 2,000 hours is approximately 25% of the number of hours in a year, the capacity factor is 25%. In concrete terms, this means that an average of 12,000 megawatt hours of energy are produced per year with an onshore wind turbine. And this is where the potential of high-altitude winds comes into play. In addition to increasing wind speed, it is particularly important that the wind is constant. The S1500 is still in the testing phase, so there are no concrete figures on full load hours yet. But other products such as the wind turbines from Alteros show a capacity factor of 60 to 75%, up to 3 times higher than normal wind turbines. By the way, I will come back to the Altru project in a moment. But let's take a look at the S1500, of course. The rated power of the S1500 is currently significantly lower. We arrive at an energy output of 6,800 megawatt hours per year with a capacity factor of 65%. That is just under half of a normal wind turbine. However, BETs are still in the middle of development, and because they can be utilized more constantly, there's potentially still a lot of room for improvement in terms of high-rated power. And there are actually also a few other arguments in favor of such plans. Let's start with a point that should never be overlooked. What about the money here? Flying power plants could actually score, at least in one aspect, because they do not need a foundation or a tower. Up to 90% of materials could be saved. Together, with a potentially more consistent output we just talked about, and the faster construction. This could reduce the cost of electricity generation, according to the manufacturer, by as much as 30% per kilowatt hour. The absence of a tower and foundation could not only make the whole thing cheaper, but also has another advantage. The expansion of wind turbines in Germany, for example, is not easy. There are a lot of protests against it because people don't want to have this in front of their houses. And besides protests, there are also other problems, like for example, the transportation of the material because wind turbines are very, very large. This is something the new system would actually solve. And also, it's way more flexible. So you can transport it to a new space because BATs do not require complex transport infrastructure and only need to be inflated on site. They can be set up almost anywhere, even in places that would never be accessible to normal wind turbines, from deserts and remote islands to offshore drilling platforms. This is, of course, a huge advantage. Current studies do not yet provide much information, but one study shows that these airborne wind energy systems have a potential of 14 to a maximum of 108 gigawatts. which would be almost as much as the expansion target for all onshore wind turbines by 2030 in the world. But I must say that the range from 14 to 108 gigawatts is of course extremely wide and therefore not very meaningful. Current studies do not yet provide much information, but one study shows, or says, that these airborne vehicle energy systems have a potential of 14 to a maximum of 108 gigawatts, which would be almost as much as the expansion target for all onshore wind turbines by 2030. But what do you think? Write it down in the comments. And here you find the video about the small modular reactors, the small nuclear power plants. Thank you so much for watching all the way to the end. If you enjoyed this deep dive, please smash that like button, share your thoughts in the comments below. And don't forget to subscribe and turn on notifications so you'll never miss a future update. We've got a lot more exciting tech stories coming your way. Until next time, stay curious, stay inspired, and we'll see you in the next video. Goodbye.